lithium forms a monoxide with the oxygen, while other alkali which also forms a peroxide and superoxide. If you look at this picture, you can clearly understand that lithium, which is almost similar to the magnesium, especially with their polarizing power. The M can be replaced with the sodium, potassium, or lithium with the cesium or with the potassium also. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called S block element. Under that, we have discussed about the chemical properties of group 1 element. In that, we have learned that how does our alkali metal react with the water, react with the air, react with the halogen and react with the carbonates and forming a different product. Is it right? And in addition to that, we also discussed about the uses of alkali and anomalous behavior of the lithium also we have learned. Today, we learn the remaining topics, the next topic of this unit, that is the general differences between lithium and other the alkali metals and the general characteristics of the compound of the alkali metals and preparations and properties of some important compound. In that, we are going to understand how do they prepare the sodium carbonate and the uses of the sodium carbonate also we are going to discuss in this session. Let's see with the differences between the lithium with the other alkali metal. Is it right? Because we already learned that lithium is one of the smallest element which is there in the periodic table, which is having the small size. Is it right? And it shows the characteristics which is different from the rest of the element which is found in the group 1. Let's see with the differences between the lithium with the other alkali metal. Some of the properties in which lithiums are differ from the other members. Here I have listed out the few behavior of the lithium with the other metal. Lithium is very harder when it is compared with the sodium and potassium. When you compare the lithium with the sodium, we know that sodium is a very soft metal. That is why we used to keep in a kerosene and we can easily cut it with a knife. But when we compare the sodium with the lithium, lithium is very harder. The melting and boiling points of the lithium are comparatively high. So when you compare the group 1 elements such as lithium with the sodium, potassium and other members, lithium have a high melting and boiling point. Lithium forms a monoxide with the oxygen, while other alkali which also forms a peroxide and superoxide. So during the reactions, we have understood that especially the potassium and cesium and rubidium, they forms a superoxide, whereas the sodium which forms what? It forms a peroxide. But when we use this lithium and comparing with the other element, we know that lithium will forms what? Only the oxide. Okay. Next is lithium combines with the nitrogen to form a nitride, where other alkali metal do not combine with the nitrogen and it do not forms a nitride. Lithium chloride is deliquescent and crystallizes as a hydrate of lithium chloride dot 2H2O, whereas the other alkali, metal alkalis which forms a chloride which do not form a hydrate, which indicates that when you take the lithium salts, when you expose to the atmospheric air which undergo hydration and forms a respective hydrides. But when you compare the lithium with the other metal do not form any hydrate when it is exposed to the air. Only thing is the lithium salts, it will form a hydrate when it is exposed to the air. That is why the lithiums are also known as deliquescent, which means to say that it can easily react with the air and forms a hydrate. Okay, that is why such lithium salts are usually kept in the airtight container. So these are the important properties or the important differences between lithium with the other alkali metals which is belonging to the group 1 elements in our periodic table. Next is diagonal relationship between the elements in the periodic table. Here I have a group 1 as well as with a group 2 element. But if you see the elements, especially the lithium as well as with the magnesium, they shows a diagonal relationship. Why does it shows a diagonal relationship? What is meant by diagonal relationship first of all, we'll understand now. Okay? The relationship within the periodic table by which certain elements in the second period have a very close chemical similarity with their diagonal neighbors in the next group and in the third group or in the third period. They are known as diagonal relationship, due to which diagonal relationship lithium shows a similarity with the magnesium due to the following reason. The first reason is the similarity in their ionic seizures and similarity in their polarizing power. Which means to say that if you look at this picture, you can clearly understand that lithium, which is almost similar to the magnesium, especially with their polarizing power as well as with their ionic size. Ionic sizes in the sense, if you remove the electron from its outermost shell, how does this ionic radius will get reduces to ionic radii, that values which is on the same when we compare the lithium with the magnesium. This shows that lithium and the magnesium, they are diagonally related to one another with their property. Okay, this is known as diagonal relationship. So when we compare the group 1 with the group 2, especially the group 1 elements known as lithium, which have a diagonal relationship with the group 2 element called as magnesium. The similarity between the lithium and magnesium with the diagonal relationship, here some of the relationship I have listed here. Both forms of chloride or bromide when they hydrolyzed slowly and soluble in ethanol. So you can see that when the lithium reacts with the chlorine, it forms what? Lithium chloride. Lithium chloride. Similarly, magnesium reacts with the chlorine and forms a magnesium chloride. So both will form a chloride and it can easily undergo hydrolysis and give rise to their respective ethanol. Both forms a colorless and slightly colored crystalline nitride by direct reaction with nitrogen at very high temperature. Both burns in air and give rise to the normal oxides only. For example, you can see that the lithium combines with oxygen and forms what? Lithium oxide. Similarly, the magnesium reacts with the oxygen and forms what? Magnesium oxide. Is it right? So, both will react with the air and forms a respective oxide. Both forms are carbonate and decomposes on heating. Oxides of lithium and magnesium do not combine with excess of oxygen to form a superoxide. So, as we have learned that, especially the sodium, it forms a superoxide when it is react with the oxygen. But our lithium as well as the magnesium, it cannot react with the excess amount of air and give rise to the superoxide. So it cannot react with the excess amount of oxygen and it cannot form what? Superoxide. Both lithium and magnesium are harder with their higher than the other element with their respective group. So when you take into the masses, both the lithium and magnesium, they are very hard compared with the other elements in the periodic table. So these are the diagonal relationship of the lithium with the magnesium with the following relationship which has been exist because of the similar characteristics. Okay. Next is general characteristics of the compounds of the alkali metal. So here I have listed out the general characteristics of all alkali metal. The first one is oxides and hydroxide. We know that all alkali metal, when it is burned with the air, it forms a different oxide. Especially the lithium will form a lithium oxide, sodium will form a sodium peroxide, whereas potassium, cesium and rubidium, it forms a super oxide. Is it right? Yes. So these are the reaction. As we know that it also reacts with the water and forms a respective hydride. So all the alkali metal and their oxides and peroxides and superoxides are readily dissolved in a water and produces a respective hydroxide. Sodium reacts with the water and forms a sodium hydroxide, or sodium peroxide when it is dissolved in water, which also gives rise to the sodium hydroxide and peroxide. Sodium oxide when it is dissolved in water, which gives rise to the sodium hydroxide along with the liberation of hydrogen gas. Similarly, potassium oxide when it is dissolved in water, which gives rise to the potassium hydroxide with the peroxide and oxygen gas will be released. This indicates that all alkali metals especially, they form oxides and hydroxide when it is react with the water and when it is react with the air. So, hope you are understood with this first general reaction. And next one is halides of the alkali metal. Alkali metal combines directly with the halogen under the specific condition to form a halide, and the general formula is Mx. These halides can be prepared by the accretion of aqueous halogen acids on the metal oxides and hydroxides as well as with the carbonates, metal carbonates. Okay. So here we have a metal oxide where it is react with the hydrogen halide. Okay. It gives rise to the metal oxide with the formation of water. Similarly, when metal hydroxide which is react with hydrogen halide which gives rise to the metal halogen along with the water molecule. Similarly, when a metal carbonate reacts with hydrogen halide, it gives rise to the metal halide with the formation of carbon dioxide water molecule. Here, the M can be replaced with the sodium, potassium or lithium with the cesium or with the potassium also. And the X can be replaced with the chloro, bromo, iodo or with the fluoro because they are the halogen. All these halides are colorless. Remember, they have a high melting and crystalline solid having high negative enthalpies of formation. They have a very high negative enthalpy of formation. Next thing is the solubility of the alkali metal halides except those of the fluoride decreases on descending order of the group since decreases on hydration energy is more than corresponding to the decreasing in lattice energy. Due to the high hydration energy of lithium ion, lithium halide are soluble in water except lithium fluoride which are sparingly soluble in water. So when you compare the lithium halide, especially the lithium halide are soluble in water, but lithium fluoride, even though it is a metal halide, it is insoluble in water because of the high lattice energy. Because of what? High lattice energy. And for some of the alkali metal, the melting point will be decreases in the order of fluoride, chloride, bromide and iodide. Okay. For the same alkali metal ion, lattice energy will be decreases as the size of the halide ion will be increases. For the some halide ion, melting point of the lithium halide are lower than that of the corresponding sodium halide. Therefore, the decreasing as we move from down the group from the sodium to the cesium, the low melting point of the lithium chloride as compared with the sodium chloride, probably because of the lithium chloride is covalent in nature, whereas sodium chloride are ionic in nature. As we move down the group, what will happen to their melting point? It will also get decreased. Why is it so? Because we know that the lithium, when it is react with the halogen, it forms a lithium chloride. Is it right? And it has a very high melting point because it forms a covalent bond. Whereas other element, if you take as sodium chloride, it has a very least melting point because it forms a ionic bond with the chlorine. Next is salts of oxo acids. An oxo acid is an acid which consists of an oxygen atom bonded with a hydrogen atom, and it has only one other element. Example is sulfuric acid. You can see that oxygen and hydrogen is there. Phosphoric acid, oxygen and hydrogen will be there, and nitric acid, hydrogen and oxygen will be there. They are known as oxo acid, which consists of one hydrogen and one oxygen atom. Since alkali metals are highly electropositive and their hydroxides are highly basic in nature, hence they form salts with all oxo acids, and generally they are soluble in water and stable towards the heat. So if you compare it with the oxo acids with the alkali metals, the oxo acids, remember that it consists of oxygen and hydrogen. Okay, they are known as oxo acids. These elements, when it is react with the oxo acids, which give rise to the salts, and these salts are usually soluble in water and stable with the heat. Next is decomposition of the metal carbonate. The carbonate of the metal alkali metals are remarkably stable up to 1273 Kelvin, above which the first will melt and then eventually decompose to give a oxide. That is, lithium carbonate will be formed. However, it will be considerably less stable and decompose readily. You can see that lithium carbonate upon heating, which gives us to the lithium oxide with the liberation of carbon dioxide. This presumably due to the large size differences between lithium and carbonate ion, which makes the crystal lattice to be unstable, and being strongly basic alkali metal, they forms a solid bicarbonate, and no other alkali metal which forms a solid bicarbonate through with the ammonium bicarbonate, which exits as a solid. Lithium, however, do not form a solid bicarbonate. Although it does not exist in a solution, all this bicarbonate will be gently on heating undergo decomposition and give rise to the carbonate. Here, if you consider the metal bicarbonate, which is upon heating, remember, it forms a metal carbonate with the release of carbon dioxide and water. But lithium cannot form some metal hydrogen carbonate, but upon heating it cannot give rise to the metal carbonate with the elimination of carbon dioxide and water. This is how the metal carbonate, which is formed from the alkali metal, which is upon heating, which gives rise to the metal carbonate with the liberation of carbon dioxide. Next is preparation and properties of some important compound. In that, we are going to study more about the sodium carbonate, and a common name is washing soda, and the molecular formula is Ne2CO3 and 10 water molecule. Sodium carbonate is an industrially important compound and is manufactured by salvary processes. In this process, advantage is taken for the low solubility of sodium hydrogen carbonate, thereby it gets precipitated in the reaction of sodium chloride with the ammonium hydrogen carbonate. The raw materials which is required for this manufacturing are brine and ammonia, and we are taking carbon dioxide and calcium hydroxides, which is obtained from the limestone. Let's see with the steps. Ammonia by solvary process, which consists of following step. First one is a step 1. The sodium hydrogen carbonate is prepared by passing carbon dioxide to the concentrated solution of sodium chloride. Remember, the concentrated solution of sodium chloride, it is known as what? Brine. It is known as what? Brine. The saturated with the ammonia. During this reaction, ammonium carbonate are followed by ammonium hydrogen carbonate formed as shown in the figure. So here I have taken out the ammonia, which is allowed to react with the carbon dioxide and forms a intermediate compound, that is ammonium carbonate will be formed. This ammonium carbonate, which is further reaction with the carbon dioxide, which forms what? Ammonium bicarbonate. This ammonium bicarbonate, when it is react with the concentrated solution of NaCl, which is known as brine, which gives rise to what? Ammonium chloride with the formation of sodium bicarbonate. With the formation of what? Sodium bicarbonate. So in the second step, sodium hydrogen carbonate or sodium bicarbonate, you can say, heated up to 300 degrees Celsius to decomposes into sodium carbonate and carbon dioxide, and sodium carbonate is recovered and the carbon dioxide is reused. So if you take the sodium bicarbonate or sodium hydrogen carbonate, if you heat this compound, which undergo decomposition and give rise to the sodium carbonate with the release of carbon dioxide and water molecule. This shows that we can reuse this sodium carbonate as a washing powder, and we can recover the carbon dioxide for the next step also. In step 3, ammonia can be also be recovered by treating the ammonium chloride with the calcium hydroxide, forming a calcium chloride and ammonia. You can see that the ammonia which we have used in this reactions, which is formed in this step, that is ammonium chloride, this will be again allowed to react with the calcium hydroxide obtained from the limestone. What it form? It will form ammonia with the formation of calcium chloride with the liberation of water molecule. This shows that whatever the compound or whatever the raw material we have used in the form of ammonia as well as with the carbon dioxide, we can easily recover from this process. This is how we can easily manufacture the sodium carbonate by using brine, by using calcium hydroxide, and also by using what? Carbon dioxide. So hope you all understood with this manufacturing. Again, this process, it is very important for the examination point of view. It can be asked for 3 to 2 marks. So entire reaction you must know. Next, we will see with the properties of sodium carbonate. Sodium carbonate is a white crystalline compound, and we know that it will be soluble in water and insoluble in alcohol. They forms a strong alkaline aqueous solution with the sodium carbonate, and it will be written as Na2CO3 H10 water molecule, which is commonly known as what? Washing soda, and it will be soluble in water. On heating, it dehydrated and loses its water molecule. Upon crystallization, it forms a monohydrate, and above 373 Kelvin, the monohydrates are become completely anhydrous and changes into white powder, which is also known as soda ash. This is another important thing we must know. Once we got the sodium carbonate, if you dissolve in a water, we get aqueous solution of sodium carbonate decahydrate, we get it. Is it right? Which is upon further heating, it gives us the sodium carbonate by eliminating all water molecule. Once it eliminates all water molecule, remaining sodium carbonate will be leave as such. The sodium carbonates are itself it is used as a soda ash. Okay. So next is hydrolysis of sodium carbonate. The carbonate part of sodium carbonate can easily get hydrolyzed by water to form an alkaline solution. So the carbonate forms of sodium bicarbonate can be easily react with the water and forms a alkaline solution. And last is uses of sodium carbonate. We know that it will be used as washing soda for especially in the laundry, we use these substances as a washing powder, and to soften the water also, for softening of water they will use this, and for cleaning also we will use a washing soda, and it is used in manufacturing of the glasses, soaps, borax as well as in caustic soda, and in paper industry, especially in the paints and in textile industry, we use this sodium carbonate, and also it is a very important laboratory reagent both in qualitative as well as in a quantitative analysis. So in the next class, again we are going to learn some important organic compound. In that we are going to learn more about the sodium chloride preparation and their uses. By this, I like to say that today I have extended some of the important things which is there in the S block element, the differences between lithium with the other element and the diagonal relationship with the lithium with the magnesium ion, and the general important characteristics of the all alkali metals also I have discussed. In addition to that, I have explained the preparations of sodium carbonate by Solvay process. Hope you understood with this concept. We'll meet you with the next session. Till that, take care, be safe. Thank you.